Getting into lesson 2 of chapter 16, we're now looking at angles of elevation and depression. We're still within the right triangle realm of things as we were in lesson 1. It's just sort of a little different concept mixed into right triangles. So for lesson 2, for elevation and depression, here's the basic right triangle diagram for that. Elevation seems to be the one that makes the most sense to people. If you were standing right here, so that's you. So if you're standing right there looking up, right, then we can see this as the angle of elevation. And that one seems to make the most sense. It's the angle of depression that, if anything, people might get this part wrong. So oftentimes people really want to put the angle of depression right there. But there's a key element here that you always have to consider. Depression and elevation are always formed with a horizontal line. So if I were to try to put depression right here, I would be breaking that rule. There's no horizontal line there connected to it. So instead, the way that we have to see depression is right here. So if I create a horizontal line, well, now that gives me a place to put my angle of depression. So now if this is you standing at the top looking down, then that is our angle of depression. So again, it has to go there because it has to be formed with a horizontal line. Well, because of that, they're both formed with horizontal lines, one of the things you learned back in geometry a long time ago was if you have parallel lines, like this horizontal line and this horizontal line, then these angles are what we call alternate interior angles. And alternate interior angles are equal. So that makes the angle of elevation always equal to the angle of depression. So that's always going to be true. Which means if I were to say something about the angle of depression, you could put that value here. Just the same as you could put the angle of elevation right there. So that's kind of your basic diagram for that. So we're just going to go through 2 problems in this lesson. The first one is a little more of the simpler version. So this one here, we have an angle of depression from the top of a tree to a person standing 50 feet away from the base of the tree. So diagram is always beneficial for word problems like this, especially in geometry. So we'll give ourselves a nice little diagram to work with here. So here's our tree. So there's our tree. Angle of depression from the top of the tree to a person standing 50 feet away from the base of the tree. So here's the base of the tree. So if we're going to put our person right about here, and it said they are 50 feet away from the base of the tree. So now when we kind of create our right triangle out of this, so creating our right triangle, so now again, just like we saw a second ago, if they're going to refer to the angle of depression being 35 degrees, remember what that would mean. The angle of depression, as you see in the diagram right above, would be right here. So if I wanted to, I could draw a horizontal line right here and stick the angle of depression right here. But with this drawing, it would make more sense to use this idea and put my 35 degrees here instead. Since elevation and depression are always equal, that's going to make more sense for this drawing. So anyway, that's what we have, and now they're asking how tall is the tree, so let's throw an X in for that idea. And now we're just solving a right triangle just like we did in our last lesson. So going back to our SOHCAHTOA idea, based on this angle that we know, that makes X the opposite leg, makes 50 the adjacent leg. So we know opposite and adjacent always goes with tangent. So if we said tangent of 35 degrees is equal to opposite over adjacent. So now we just solve for X. So if we multiply our 50 over to here, in our calculator we're going to throw in 50 times tangent of 35. Should be in degrees for this as always. So that leaves us with X equaling 35.0 since we want to keep our 3 sig fig rule, so we'll put 35.0. Alright, moving on. So the last one that you're seeing down here, a little tougher, but for this one, this is a little more par for the course as far as the level that we need to be able to do. So for this one, the kind thing about this problem is that it's been drawn for us. You're going to run into some cases where you got to come up with your own drawing, and those are the ones that can be a little challenging because you can see there's a lot going on here, and so it does definitely helps to already have the diagram to work with, and all we have to do is solve for stuff. So everything that's already been described is already laid out for you within the diagram itself. So where they refer to building A and building B, the 40 meters has already been put in place, the 65 degrees. So everything's already been identified within the drawing. So what they are asking for is how tall is building B. So you can see right here, this is building B, and we're going to figure out how tall that is. So just starting to work through this, a little piece of advice whenever you get problems like this that are multi-step problems, if you don't see right off the bat how you're going to get to this stage, just start plugging in whatever you do know. So whatever you can find, start solving for those things. So one thing we'd like to notice right off the bat here is the right triangles that are being formed. And so if you look at this right triangle, let me kind of fill in the lines here. So if you look at this right triangle that is being formed with building A, all right, there's something we can work with. We know this is Y, which means this is Y. Those would be the same values. So if we do a little right triangle trig here, we can get our Y value out of this. So based on that triangle, we can do a little tangent for opposite over adjacent. So let's start there and say tangent of 65 is equal to opposite over adjacent, so Y over 40. And if we solve that in our calculator, so multiply the 40 over to here. If you go into your calculator and hit 40 tan 65, you're going to come out with a Y value of 85.780. I'm going to go a few decimals deep simply because we're not done yet. So I don't want to round off too shallow. If I'm going to need this value to do something else, I want to go a little more exact, a little deeper into my decimals since I'm not done with the problem yet. So I want to make sure that my ending answer comes out nice and accurate. So a little deeper on the decimals while we're still in the middle of the problem. So we now know the height of building A. So the next key is if we look at the overall big picture, what we need to see on this is if I'm going to find building B, basically what I'm going to need to do is, since I have this value to work with, is to find the height of building A, and then if I subtract out this piece right here, right, which we're calling X, if I subtract out this, well then that's going to leave me with the height of building B. So if we can find the X value, then I can just do the Y value minus the X value in order to get building B. So let's see if we can solve for X. So if we take that same X and translate it over to right here, then I now have another right triangle to work with. So let's put X right there. And we got the 35 degrees sitting right there, so let's kind of form the, let me do it in a different color, form the red right triangle that we're going to work with in order to solve for X. So let's make that a red guy right there. So there's the red rectangle that we're going to solve for X. So now in this case, again, that same 40 would also be this 40. So keep that in mind. So that's one of the keys to doing these, is to be able to move these items into anywhere on the diagram that would make sense. So now you can see the red right triangle that we have. And again, now I can do another tangent process in order to solve for X. So in this case, we can now say tangent of 35 equals X over 40. And we can work with that one. So now if we multiply the 40 over to the left, all right, we can solve for X. So if you go into your calculator and hit 40 tan 35, so 28.008. And again, just for accuracy's sake, I like to go a little deeper than just the 3 sig figs until I'm done with the problem. Then I'll go to 3 sig figs, and I'll be more accurate this way. But now I can figure out that building B by just subtracting those two values, and their difference should come out to be 57.8 approximately. And that's it. For you IB people taking the IB test, remember you always want to include things like the units, so like feet in this case, or meters, or whatever it is that they're referring to. That's something you always want to include into your answers. So in this case, let me throw in a little meters right there for that one.